Okay, dear students, now today let us work some problems regarding frequency modulations. We have obtained the expression for the voltage of the frequency modulations, and also we have studied how the frequency modulated wave is generated using reactance tube modulator. Now we will work out some problems on those. The first problem. See, the first problem is this. It is given that if a frequency modulated wave is represented by the voltage equation E equals 10 sine of this value, then you calculate all these things. Calculate the modulating frequency FM, that is message signal frequency. Calculate the carrier frequency FC, that is the frequency which will carry the message signal, carrier frequency, and depth of modulation, that is modulation index, MF. Modulation index is M, F suffix stands for frequency modulation, MF. And maximum frequency carrier deviation. Before modulation the frequency was FC. After modulation the frequency deviates from FC to the maximum value or to the minimum value depending upon the amplitude of the message signal, whether it is maximum amplitude or minimum amplitude. And also you have to calculate what power will this FM wave dissipate in a 8 ohm resistor. After generation of frequency modulated wave, we had to transmit it into space as electromagnetic radiation, and this will travel in this space as electromagnetic radiation. We can capture these electromagnetic radiations wherever you want on the earth. So to do so, the FM wave generated is applied to an antenna where it radiates the signal into space as electromagnetic radiations. So it is given that the antenna resistance is 8 ohm. Therefore, what is the power radiated by the antenna when the FM wave is applied to the antenna? All these you have to calculate. First, write the given equations. The given equation is instantaneous voltage is equal to 10 sine. I will write the given equation. E is equal to 10 sine of this. Therefore, E is equal to 10 sine within bracket 8 into 10 power 8 t plus 4 into sine of 1500 into t. It is given. Now compare this with general equation of frequency modulated wave. The general equation is instantaneous voltage of the frequency modulated wave EFM is equal to EC, carrier amplitude remains constant during frequency modulation, and this is sine of, we know that it is omega CT plus MF sine of omega MT. Now compare these two equations. So modulating frequency, first you have to calculate modulating frequency FM. See where in this equation where is omega m? Omega m is there. Instead of that, it is given 1500. Therefore, for the first one, the omega m is equal to 1500. But we know that omega is 2 pi f. Therefore, omega m is 2 pi fm. Omega m is 2 pi fm into 1500. Therefore, Fm is equal to 1500 divided by 2 pi. On calculating this, you will get the value 1500 divided by 2 pi. 3.14 pi is So you get 238.85. 238.85 units hertz. This is our modulating frequency, low signal frequency. Second one, you have to calculate carrier frequency Fc. Compare these two equations. Omega c, instead of omega c, it is given 8 into 10 power 8. Therefore, to calculate carrier frequency, second one, omega c, on comparison, we get it is 8 into 10 power 8. Omega is nothing but 2 pi Fc is equal to 8 into 10 power 8. Therefore, from this expression, carrier frequency Fc is equal to 8 into 10 power 8 divided by 2 pi. On calculating this, you will get divided by 3.14, which is equal to 1.274. 1.274 into 10 power 8. I will write this as 127.4 into 10 power 6 unit is hertz. Therefore, this is equal to 127.4. 10 power 6 is megahertz. Okay, this is the carrier frequency. Next one, what we have to calculate, carrier frequency Fc. After that, modulation index MF. See these two equations. Instead of MF, it is given 4. Therefore, third one is modulation index MF is equal to 4. Next, and maximum frequency deviation. By the definition, we know that modulation index is equal to maximum carrier frequency deviation delta divided by FM. Therefore, maximum carrier deviation delta is equal to MF into FM, which is equal to MF is 4, FM we have calculated as 238.85. Therefore, this is 238.85 is equal to, on calculating this, you will get 4 into 238.85 is equal to 955.4. 955.4 unit is hertz. So carrier deviation is 955.4 hertz. Okay, the last one. When this FM wave is applied to an antenna of 8 ohm resistor, a power is radiated by the antenna. That is, next one is fifth one, power radiated by the antenna. FM wave, I will call this as PFM, power of FM wave. We know that by definition, power is equal to voltage into current or voltage divided by resistance. Therefore, this is equal to AC voltage. I will write this as ERMS, voltage squared divided by R. Because we know that power is equal to V squared by R is the formula. The power of FM wave is given by voltage squared divided by R. Therefore, here voltage we have mentioned is E, and it is E squared RMS by R. What is E or ES? Both are same. The voltage E is 10. Compare these two. Instead of EC, it is 10 volts. Therefore, this is equal to ERMS 10 divided by root 2 whole squared. Because RMS value I have to take. If E or EC is equal to 10, 10 by root 2 is RMS value. EC is equal to 10 volts is the DC value, direct value. For AC, it is 10 by root 2. This is converted to AC by dividing it by root 2. Therefore 10 by root 2 whole squared is AC signal of FM wave divided by the resistance is 8, which is equal to 100. 10 square is 100. Square root of square is 4 divided by 32. On calculating this, you will get 100 divided by 32, which is equal to 3.125. You will get 3.125. Unit of power is watt. So this is the first problem regarding FM wave. Now let us calculate. Now let us consider the second problem. The second problem is given like this. Okay. In a frequency modulated system, the modulating frequency, that is FM, and the voltage, modulating voltage, that is EM, are respectively 800 Hz. That is FM is 800 and capital EM, modulating voltage, is 3 volts. The deviation ಎಷ್ಟಾಗುತ್ತೆ carrier frequency depending upon this 3 volts is the maximum deviation ಆಗುತ್ತೆ. Deviation of carrier frequency is 6.3 kilohertz. Therefore first I will write the given parameter. First one is what? Modulating frequency FM1, I will call it FM1, that is 800 Hz, and EM1 3 volts. Delta is 6.3 kilo ohm. Therefore FM1 is 800 Hz and EM1 modulating voltage, first modulating voltage is 3 volts and delta is equal to 6.3 kilo ohm. These three are given. Continue the problem. If the modulating voltage is increased to 4.5, it was given 3, then it is increased to 4.5. Aga calculate the new frequency deviation. If it was 3 volts, it is 6.3. When this 3 volts is raised to 4.5, what is the new frequency deviation? Therefore, when EM2 is equal to 4.5 volts, second case, when EM2 equals 4.5 volt, what is the new deviation? Delta nu is equal to how much? Continue the problem. If the modulating voltage is raised to 7 volt, ಅಂದರೆ ಈಗ EM2 ಎಷ್ಟಿತ್ತು 4.5 ಆಯಿತು. ನಾವು ಐ ರೈಸ್ ಟು 7 ವೋಲ್ಟ್, 7 ವೋಲ್ಟಿಗೆ ರೈಸ್ ಮಾಡಿದ್ರೆ ದ ಮಾಡ್ಯುಲೇಟಿಂಗ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಈಸ್ ರೆಡ್ಯೂಸ್ ಟು 500 ಹರ್ಟ್ಸ್. 800 ಹರ್ಟ್ಸಿಂದ 500 ಹರ್ಟ್ಸ್ಗೆ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಯಾವಾಗ ಮಾಡ್ಯುಲೇಟಿಂಗ್ ವೋಲ್ಟೇಜ್ನ 7 ವೋಲ್ಟ್ಸ್ಗೆ ರೈಸ್ ಮಾಡಿದಾಗ. ಆಗ ವಾಟ್ ಈಸ್ ದಿ ನ್ಯೂ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿವಿಯೇಷನ್? ಡೆಲ್ಟಾ ಎಷ್ಟು ಆಗ? ಅಗೈನ್ ಆಲ್ಸೋ ಕ್ಯಾಲ್ಕುಲೇಟ್ MF, ಮಾಡ್ಯುಲೇಷನ್ ಇಂಡೆಕ್ಸ್. ಆಲ್ಸೋ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಯುಲೇಷನ್ ಇಂಡೆಕ್ಸ್ ಇನ್ ಈಚ್ ಕೇಸ್, ಪ್ರತಿಯೊಂದು ಕೇಸಲ್ಲೂ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ಅದಕ್ಕೇನು ಮಾಡಬೇಕು ನಾವು? ಫಸ್ಟು ಡಿವಿಯೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಆಗ್ತಾಯಿದ್ರೆ ಡಿವಿಯೇಷನ್ನು ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಡಿವಿಯೇಷನ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದಿ ಆ್ಯಂಪ್ಲಿಟ್ಯೂಡ್ ಆಫ್ ದಿ ಮಾಡ್ಯುಲೇಟಿಂಗ್ ವೋಲ್ಟೇಜ್. ಸೊ FM1 given modulating frequency 800 Hz. Modulating voltage, first modulating voltage 3 volts. For that the deviation is 6.3 kilo ohm, unit of this frequency deviation. Frequency unit is hertz, kilohertz. Therefore you have to calculate what is the deviation per volt. 1 volt ಗೆ ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. I will call this as deviation per volt, which is equal to 1 volt ಗೆ ಎಷ್ಟು ಅಂತ. So 6.3 kilohertz for 3 volts. Therefore deviation per volt is 6.3 k by 3. This is 3.1 kilo unit is hertz per volt. 1 ವೋಲ್ಟ್ಗೆ 3.1 ಕಿಲೋ ಹರ್ಟ್ಸ್ ಆಯಿತು. ಎರಡನೇ ಕೇಸಲ್ಲಿ ಏನು ಕೇಳಿದ್ದಾನೆ, ವೆನ್ 3 goes to 4.5 ವಾಟ್ ಈಸ್ ದಿ ನ್ಯೂ ಡಿವಿಯೇಷನ್. therefore ನ್ಯೂ ಡಿವಿಯೇಷನ್ ಈಸ್ 1 ವೋಲ್ಟ್ಗೆ 3.1 ಆದರೆ 4.5 ಎಷ್ಟು, ದಟ್ ಈಸ್ 2.1 kilo into 4 which is equal to 8.4 kilohertz. Next case, if the modulating voltage is raised to 7 volt, when EM2 goes to 7 volts, when EM2 goes to 7 volts, rises to 7 volts, the frequency reduces to 500 and the frequency FM reduces to 500 hertz. What is the new deviation? The new deviation is now for 7 volts, and we know that deviation per unit volt is equal to 3.1 kilohertz. Therefore for 7 volts, what is that? Therefore for 7 volts, I will call this as delta nu dash. Another deviation is equal to 1ಕ್ಕೆ 3.1 ಕೆ ಆದರೆ ನೆಕ್ಸ್ಟ್ 7ಗೆ ಎಷ್ಟು ಇಂಟು 7 ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 21.7. So it is given when EM2 is raised to 7 volts, FM reduces to 500 hertz. And we know that deviation per unit volt, 1 voltಗೆ 3.1. Then what is the new deviation? Delta nu dash. So 3.1 is for 1 volt. For 7 volt, what is the deviation? 3.1 kilo into 7 is 21.7 kilohertz is the unit. Now we have to calculate modulation index in each case. Okay. Modulation index in the first case. See this. For the first one, the frequency is 800 Hz. Therefore, MF is equal to, we know that it is delta divided by FM. For the first case, deviation, where is the deviation, is 3.1 kilohertz per unit volt. And for that, FM is 800 Hz. Therefore, MF is equal to 3.1 kilohertz divided by FM is 800. On calculating this, you will get 3100 divided by 800 is 3.875. It is 3.1 kilohertz for the first deviation. 800 is the hertz. By definition, modulation index is carrier deviation delta divided by modulating frequency. That is 3.1 kilohertz for delta. FM is 800. And dividing this, K is 1000. After calculating this, you will get 3.875. First one. Now second. What is MF for second? The MF for second is, what is the modulating voltage? The modulating voltage was 7 volts. Therefore, new frequency deviation for that is 7 volts per division. Deviation per volt is, for the second one, new deviation C is 21.7 kilohertz. Therefore, modulation index MF2 second case, it is delta divided by FM, where delta new deviation is 21.7 kilohertz. 21.7 kilohertz. In the first case, frequency remains constant, only voltage is raised from 3 to 4.5. Frequency does not change. Therefore, frequency is 800. On calculating this, you will get 21700 divided by 800 is equal to 27.125. 27.125 is the modulation index. And finally, final modulation index. In the final modulation index, what is the deviation per volt? Deviation per volt is 3.1 kilohertz, whereas only frequency changes. Frequency changes. Therefore, for the third modulation index, MF, it is delta by FM dash. Delta is for unit deviation. Deviation per unit volt, 3.1 kilohertz divided by FM. Frequency is reduced. Therefore, frequency reduces to 500 from 800. Therefore, new frequency deviation is 3100 divided by 500. 6.2. You will get 6.2. MF equals delta by FM dash. Only frequency changes 800 to 500. Then deviation remains constant. Deviation per unit volt is 3.1 kilohertz. Divided by frequency now change to 500. Delta by FM. Substituting and calculating, you will get 6.2. No unit, because modulation index MF above is delta carrier deviation, that is frequency deviation hertz. Below is also frequency hertz. Hertz get cancelled. Therefore, ratio is not having any unit. So, this is our second problem. Okay, now we shall go to the next problem, third problem. And in this third problem, it is given that calculate the bandwidth requirement for the frequency modulation signal having a modulating frequency 3.1 kilohertz and the maximum carrier deviation 21.7 kilohertz. Data given. What are the data given? Modulating frequency FM is equal to 3.1 kilohertz and the carrier deviation delta is equal to 21.7 kilohertz. There are two methods, but I will simplify this using a simplest method that we have already discussed in frequency spectrum, where the bandwidth of the frequency modulated wave W is equal to bandwidth of FM AM modulation is simply 2 FM. Whereas in frequency modulation there is a carrier deviation. The bandwidth is represented as 2 into FM plus delta. Therefore, that is equal to 2 into FM is 3.1 kilo. That is 1000, mind it. 3.1 kilo means 3.1 into 1000. Plus carrier deviation is also in kilohertz. 21.7 kilo. Adding these two and multiplied by 2, we get the bandwidth as 3.1 plus 21.7 is equal to 24.8 into 2 is equal to 49.6. 49.6 unit. This is kilo. Unit is hertz. Bandwidth is measured in terms of hertz. So this is a very simple problem. Now let us work out the problem for generation of FM wave using FET modulation. reactance modulations. In this, I will do one problem and I will say how to do the remaining problems. Work out yourself. Here it is given that evaluate the value of capacitive reactance. Evaluate the value of capacitive reactance. Therefore, given ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಬರ್ಕೋಬೇಕು. From a reactance FET having transconductance of 10 millisecond. First I will write the given transconductance is denoted by GM. It is 10 millisecond. That is equal to 10 into 10 power minus 3 second. Next, the gate to source resistance. And we know that in FET reactance tube modulator, a resistance R is connected between the gate and the source. That is given as 1/6 of, see, the gate to source resistance, that is R, is 1/6 of the resistance of the gate to drain. You know, gate to drain, what component is connected for capacitive reactance? At the output, capacitance is connected. Therefore, let Xc is the capacitive reactance. Now, the frequency of operation is 4.6 kilohertz. Frequency of operation F is equal to 4.6 kilohertz. 4.6 kilohertz. R is 1/6 of reactance Xc, because C is connected between gate and drain and this reactance is Xc. Therefore, R is 1/6 of Xc, where Xc is the reactance of capacitive reactance. Now, frequency given as 4.6 kilohertz, operating frequency, that is 4.6 into 10 power 3 hertz. How to calculate this? You have to calculate what? Evaluate the value of capacitive reactance. Capacitive reactance. That is, we have to calculate Xc. And we know that the expression C equivalent, that is it is the output value of a FET transistor. It is a capacitive reactance, is given by GM into RC. Okay, C equivalent is GM into RC, which is equal to GM into C into R. What is R? R is equal to, you just write, I will consider Xc. So Xc is equal to 1 over omega C, that you know very well, which is equal to 1 over 2 pi f. Omega is 2 pi f into C. But I will consider Xc equivalent, which is equal to 1 over omega C equivalent, which is equal to 1 over 2 pi f into C equivalent. We know that C equivalent, omega is 2 pi f. C equivalent is GM RC. I will consider this as GM into RC. So Xc equivalent is equal to, I will write this as 1 over 2 pi Fc into 1 by GMR. Just I will rearrange this. 1 by 2 pi F C Ilberkotini into 1 by GMR. 1 over 2 pi Fc is Xc into 1 by GMR, which is equal to, and it is given that Xc is, R is 1/6 of Xc. Therefore, this is Xc divided by Gm into R is given as 1/6 of Xc. Therefore, this is 1/6 of Xc. Xc get cancelled, you get 6 by Gm, which is equal to 6 into Gm is 10 divided by 6 divided by Gm is 6 divided by gm is 6 over 10 millisecond, 10 into 10 power minus 3. 6 by 10 is 0.6. When it goes up, it becomes 100,000. That is equal to 600 ohm. That is our XC equivalent. XC equivalent is 600. What is it asked? Value of capacitive reactance. XC equivalent. C equivalent is equivalent capacitance. XC equivalent is equivalent capacitive reactance. That is given by 600 ohm. Thank you, and you please go through all these problems and you may be asked at any time. Thank you.